very much, students. Today I do want to take this theorem. It's a very important theorem. The matching M of a graph G is maximum if and only if G has no M augmenting path. So two things we have to prove because of if and only if comes here. One is forward proof, we know already. Another one is backward proof. Forward proof, we are assuming that M is a maximum and we prove that there is no M augmenting path. And the backward proof, we assume that there is no M augmenting path and we have to prove that M is a maximum, maximum matching. Taking the first proof, forward proof. Now we are assuming that M is a maximum matching. Okay, let M is a maximum matching. So that is what our assumption. There should not be any other matching, so that it becomes less than that. So that's what we are going to prove now. Now I am supposing that P is a path V0, V1, V2, that V2 T plus 1 is a M augmenting path in G. It's one of the augmenting path in G. Now I can define another matching M dash such as M union of this particular path and subtracting the vertices V1, V2, V3, Vt. Now this implies M dash is a matching of G with cardinality M dash equals M plus 1 because the cardinality of M plus 1. Already we have M and 1 path we have taken into account, therefore the cardinality of M dash must be equal to M plus 1. So this is a contradiction to our assumption that M is the maximum matching here. So this contradiction should not be there. Okay, therefore our assumption M is a maximum. That is true because we have proved that there is another matching M dash. That should not be the case because we have already assumed that M dash is a maximum. Therefore the contradiction comes. Coming to the second proof from backwards, assume that there is no M augmenting path. There is no M augmenting path. What we have to prove? G is a maximum. That's what we have to prove. Okay. So let G has no augmenting path. Then we have to say that we have to prove that M must to be a maximum. That's what we have to prove. Yes, it is true. If it is not true, assume that M dash is a maximum. If M dash is a maximum, then we can define a symmetric matching there, G of M intersection M dash H, a symmetric matching. We know that what is a symmetric matching. The symmetric matching is one whose initial and final point end in G dash as a cycle or as a path included in M dash, which implies that M dash is greater than M. So we must understand that M dash is a maximum. We have assumed, but here M dash coming as a maximum. It is a contradiction to our assumption that M dash is a maximum. Therefore there exists a augmented matching M dash which is greater than M. So this is against goes our assumption, and thus it is a contradiction exists here. Therefore forward proof also is proved and backward also proved, and thus we come to the end of this particular theorem. Thank you.